Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's very hard puzzle, and it's called The Enchantments by 789. Oh, okay. I thought it was I guess his name could be also 789, but I think 789 is what he was going for, but maybe his name is actually Nate and stuff. So, interesting name. Let's get to the rules. We have chaos deconstruction slash numbered regions, where in the grid we need to fill some cells with a digit from 1 through 9, such that no digit repeats in any row or column. We also need to divide the filled cells into 9 orthogonally connected regions, each containing a set of the digits 1 through 9, respectively. In the upper left-hand cell of each region is a region number, n, and this number is different for all regions. So, as an example, an orthogonally connected region is basically 1, 2, 3, 4, 5, 6, 7, okay. An orthogonally connected region means that you can connect from any cell in that region to any other cell in the region just by going through edges, all while staying within the region. So this is, for example, a valid orthogonally connected region. This would not be, because to get from this cell to any other cell in the region, you would either have to either cross by a corner, or you would have to go outside the region, going through an edge. This is not a valid region because even though they can connect to each other just by going through edges while staying within the region, they cannot connect to any other part of the region by going through edges, all while staying within the region. And the upper left-hand cell of each region, which is basically the leftmost cell of the top row of the region, is the region number. So this would be the region number because it's the leftmost cell of the top row of the region. Is the region number. And for each region, that region number is different. So there are no repeats in the region numbers for any region. We also have a German whisper loop, where we need to draw an orthogonally moving loop through the non-empty cells, which does not touch itself orthogonally or diagonally, on which adjacent digits differ by at least 5. So, as an example, we could have an orthogonally connected loop. So basically, what it means is, which does not touch itself, it means that every cell on the loop must have, and you have to draw it through the non-empty cells. So it means every cell on this loop must share an edge with exactly 2 other cells on the loop. And if it shares a corner with any cell on the loop, it has to be a neighbor or another cell that shares a neighbor, right? So this specifically shares edges only with 2 cells in the loop, and any corner that it shares is essentially either a neighbor or they share a neighbor, right? So this is a valid orthogonally moving loop. This, however, would not be, because you would be touching itself diagonally, right? You're sharing a corner with another cell in the loop, which is not a neighbor or which shares a neighbor, right? They don't share neighbors, and they're not a neighbor. So that's an example of how the German whisper, and every cell in the loop has to have a difference of all adjacent digits on a loop differ by at least 5. So for example, if this were a 3, these digits would have to be 8 or 9, because those are the only digits which can be 5 or more away from 3. Okay, within a region n, the loop must visit exactly n minus 1 cells. And the regions are visited in ascending order, excluding region 1. With region 9 connecting to region 2. Okay. So within a region, n, the loop must visit exactly n minus 1 cells. And of course, obviously, region 1, the loop must visit exactly 1 minus 1 cells, which is 0. So in region 1, the loop does not actually visit that region. In region 2, the loop must visit 2 minus 1 cells, which is 1. In region 3, it must visit 3 minus 1 cells, which is 2. In region 9, it visits 9 minus 1 cells, which is 8. Interesting. So region 9 cannot be a box then, because it will not be able to touch itself. The loop cannot touch itself. And basically the regions are visited in ascending order. So that means you must visit region 2, then visit region 3, then visit region 4, then visit region 5, 6, 7, 8, 9, and then back to 2 again. Because, of course, obviously the loop doesn't visit region 1. Okay, circles mark every instance of a region number that is visited by a loop. So that means the region number, when it's visited by a loop, so all the circles are essentially on the loop, essentially. And they're also region numbers, which is the leftmost digit of the topmost cell of a region. Arrows indicate the number of loop cells in the indicated direction, not including the cell itself. Cells with multiple arrows sum each direction separately. Oh. That means it's the same, that digit, so this digit would have to be the same, and would say that we have the same number of digits going this way as the same number of digits going that way. Interesting. And so this is hard because this obviously doesn't work for this loop. But this arrow would be, that's 1 and 2 digits that are on the loop. So if this loop were correct, which it isn't, obviously, cells with multiple arrows sum each direction separately. Yeah, I think what it means is that basically it's for both directions. So for both directions, this number must see the same number of loop cells in that direction as in this direction. Okay. So therefore this example would see 2 cells in this direction. This would see 1. This would see 2. This would see 0. This wouldn't work, and that's why this loop doesn't work, because the cells with multiple arrows sum each direction separately. So that means this must be the same sum, and this must be the same sum of loop cells. So that's an example of how the arrows work. Cage cells contain a digit equal to the number of cells seen vertically and horizontally, including itself within its region. And region borders block sightlines. So, say this were a region. Let's do something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Say this was a region. This cell would see 1, 2, 3, 4, 5, 6, 7, 8 cells in its region. So it would be 8. Let's use an example where it is blocked. So say it was, that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would only be 5 because it would be blocked by a region border, right? It would not see this cell. It would see all of these cells in the region. And then finally, all cages are given. So we have the negative constraint for the cage cells. So that means any cell in a region that matches the number of cells in its region that it sees, including itself, are all given. So they are all of these caged cells. Interesting. And there cannot, if this was, so this could never be 7 because it would see 1, 2, 3, 4, 5, 6. Assuming this region is correct, this would never be 7 because it would see 1, 2, 3, 4, 5, 6, 7, but not have a cage around it, which means it could not be 7 in this cell. Similarly, this can't be 5, this can't be 3, etc., etc. Anyways, those are all the rules. There are a decent amount of them, and this is a very hard one, so this might take a while. Anyways, if you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so all the circled cells are on the loop. This is going to be interesting. I don't know how I want to color things, but all the circled cells are on the loop. And they are different digits. They are the leftmost of the topmost cell in the region. So we do know that this is a border here. This is a border here. Obviously, there's a border around the, well, not really a border around everything. This is a border here. Because you cannot have another cell in that region be to the left or above it. Okay, so this is also the topmost cell of that region too. So this is there. I guess that's a border too. All the cages indicate a digit equal to the number of cells seen vertically and horizontally, including itself. So all cages are at least 2, because each cell in the region has to be orthogonally connected to at least one other cell in the region, right? So these are at least 2. In region 9, oh, that's interesting. So, again, the German whisper line has to be in every cell, has to be in n-1 cells in a region. So, in region 9 specifically, the German whisper loop must be in 8 of the cells, which means the only cell it can't be in is the 5, right? 5 cannot be on the German whisper loop, ever, in normal Sudoku. So it must be... So then 9 must be one of these circles. interestingly enough. Because it must visit all the digits 1 through 4 and 6 through 9 in the 9 region. The other ones we're not sure. 5 cannot be on the German whisper loop. So these digits have to be 2, 4, 2, 3, 4, 6, 7, 8, and 9. Okay, so that's interesting because since the loop moves orthogonally, it's going to form a checkerboard pattern, right? So this has to match if this is low, it has to match a high here, which makes that low, which makes that high, which makes that low. So these two are the same type of set, right? They're either both low or both high. So that would mean, okay, so these would then match one set, so we're going to make it yellow. And these would match another set, so this would be orange. So, interesting. And the reason why is because on a German whisper line, you'll alternate between low digits and high digits on that German whisper line. Interesting. And so you'll always alternate between low digits and high digits, which means to get to any cell in that region and still be on the German whisper line, it has to be, you'll have to alternate, right? So that means this is a different set than these. That's interesting. If the 7 here is on the German whisper loop, it will be a high digit. But we don't know. The circles are the only ones we know that are in on the German whisper loop, though. So, I don't know how helpful this is. We know these are of a certain set, and this is of a certain set. So if this is the 9, if this is the high, this has to be a 9. Otherwise, it's 2, 3, or 4. If these are on the loop, if they're all high, one of them is a 9. If they're all low, it's 2, 3, and 4 specifically. Interesting. How does that work? This cannot be 2, 3, 4 specifically. If this is 2, 3, 4, that would mean for the 2, the loop would only enter the region, the cell, which has its how do you say it? Which has its region number in it, which is 2. But it would have to connect to 9 somehow. Actually, I guess it could. None of these can connect to the 9 region. But this could potentially, right? If it goes this way. But then the 2 must connect to the 3 also. So the 2 has to connect to the 3 region, which has 2 digits on the loop. And the 3 and the 4 would have to be these, right? This yellow region here cannot go above this, so it can't be connected to any of these cells. And there's only one cell in the 2 region, which is on the loop. So if we try to have this as 2, 3, 4, the only region this could connect to would be here. And it has to connect directly, right? It must be 2 connects to 3, which connects to 4, which connects to 5, 6, 7, 8, 9, right? So and the problem with this is that this region, if this is the high digit, these are all lows. So this must be the 2, 3, and 4. So one of these is the 2 region, which is a single digit connected. It can't be this one because then, well, yeah, it can't, well, technically it could. It could go something like this. Or some, well, it can't be both of these because this has to orthogonally connect to another cell in the region. Um, um, so again, if this is 9, these are definitely on the loop, so they have to be low because again, you have high, low, high, low, high, and low. And any way you get there, you always, since it's always moving orthogonally and it always alternates between low and high, any way you get to this cell, this will always be a low. Um, so this can never go beyond above this row as a region, and it can't go to, or it can't be to the left of this cell, and it can't be above this cell. So this cell region can never get this way, and it can never go this way, right? So for this region, to connect to a 2, which only has one cell on the loop, it could not connect to either of these, so it would connect to here. But the problem is the 2 must be connected to the 3 also on the loop, because each uh, each with okay, yeah, the regions are visited in ascending order. So that means 9 must be connecting to 2, and 2 must be connecting to 3, and 3 must be connecting to 4. Well, none of these are connected because 2 would have to be connecting directly to 3, and then so these all have to be high digits, and this must be a low digit. So this is 2, 3, or 4. It can't, well, it could be 2. Unlikely, though. Actually, it can't be 2. 2 would have to directly connect to 3, and also it would have to connect to 9. I guess it could connect to 8, maybe? So one of these is guaranteed to be 9. You know that for certain. So does that mean then that it must, for every region, you have to connect to all the loop cells in that region? Interesting. So the single digits must be on the outside. So it has to be something like, okay, so 9 has to connect to something on the 2. So that means every cell in the region that's on the loop, it must be essentially all connected. It cannot be non-connected. Because otherwise, there's no way that the loop would visit in ascending order. Right? There's no way you could have 2, then 3, then 4 if you go back to like a, you know, you can't go 2, 3, 4, 5, 6, 7, 8, and 9, and then the 9 going back to something else and then going back to itself, right? So the 9 has to be 4, 9, then 3, 8, 2, 7, 1, 6, and then it would go back to a 1. Or the 4 would go back to a 9. And we know the 2 then must have as its digit that's on the loop a 1 or a 9 for that to work. So it cannot be 2. So this must either be 3 or 4 because it cannot be 2. 2 could not include itself on the loop. 2 would have to have either a 1 or a 9 to be connected to region 9, which is, again, starts with 4, goes to 9, 3, 8, 2, 7, 1, 6. And then the 6 goes to either a 1, the 4 goes to a 9. Okay, so let's mark them. So what, in the 9 region, you have 4, 1, not 4, 1, 4, 9, 4, 9, 3, 8, 2, 7, 1, and 6. In the 8 region, we don't know. For the 2 region, so we have 9, 8, 7, 6, 5, 4, 3, 2. In the 2 region, it's either 1 or 9, because it must be connected to the 4 or the 6 at the end. For the 3 region, you have 2 cells. So let's just remove this for now so that we can get a clear glimpse. For the 8 region, oh, that's interesting. It's either 4 digits which are the same. You have to have 4 digits of the same set and then 3 of the other set. So it's either going to be starting with 9, 3, 8, 2, 7, 1, 6, or it's going to be 1, 7, 2, 8, 3, so 1, 7, 2, 8, 3, 8, 4. Interesting. So the only difference, okay, so this is 1, 1, 9, 4. There we go. So the only difference one is the last one, right? So you're going to have 1, 2, 3, and 7, 8, 9. For the 7 cage, you're going to end in a 4 or a 6, which means 1 or 9 has to be the end. You have 2 unique digits next to it. Or a digit that has to be between 2 unique digits on the German whisper loop. So 7 doesn't have to actually follow a pattern per se. So we're guaranteed an 8 in the 8 region, having it being on the loop. We are not guaranteed a 7 or 6 being on the loop. We are guaranteed a 1 and a 9 having to be on the loop. Okay, so let's say it was going this way, right? So say it was, this was 9, this was 3, 8, 7, 2, 6, and 1. It kept, wait, that's not right. 9, 3, 8, 2, 7, 1, 6. There we go. So 8 would be in the middle. Seems possible. This would have to be next to a 1 guaranteed. That would be next to 7, 8, 9. It would have to be 7, 8, 9 then. Because the ending digit could never be a 6. Because it would not be next to a 1 in the region. So it would have to be something like, this would have to be 2 and 3 as a pair. So this digit couldn't be 7. These would all be 7, 8, and 9 triplets. This is 2 and 3, 2 and 3. So this could not be 7 here. But 7 could be in either of these spaces here. So that means you have this going to 9. Then you have 3, 8, 2, 7. Because the German whisper loop must essentially stay within that region. It must be 9, 3, 8, 2, 7, 1, 6. This 6 would go to a 1 in the 2 region, which would then be 6, 7, 8, 9, followed by 1 through 4 in the 3 region. So that would mean the 6 region would have to start with 1 through 4, right? Because so you have 4 connecting to the 9 in the 8 region. So then it's 9, 3, 8, 2, 7, 1, 6. That must connect to a 1 in the 7 region, which is followed by 7, 8, and 9. So if this is 7, this is 2, this is 8 or 9, 3, 8 or 9. Otherwise, this is 7, that would be 2. You'd have 8, 9, 3, 8, 9 then. So this would be 1 through 4 starting in the 6th region. So this way, I think the 7 is guaranteed to have a 7 in that region. So this must then be 7, 8, and 9 here. Right, okay, so this is if it goes this way. So 1, 2, 3, 4. You have 7, 8, 9 in the middle. 1, 2, 3 in the middle, followed by 7, 8, 9, and then 1 through 4 on the outside. In the 5 region, you have 4 digits, so that would be 6, 7, 8, 9, 1, 2, 3, 7, 8, 9, 1, 2, 3, 4. In the 4 region, you would have 6, 7, 8, 9. In the middle, 1, 2, 3, and 6, 7, 8, 9. Oh, interesting. Right? So it goes, connects here, connects here, connects here, connects here, connects here, connects here. So this could never be 4 in that instance. So this would have to be a 3. That's connecting to an 8 or 9, and an 8 or 9 here. So possible. And you'd have 7, 8, and 9 as the high digits that are the region numbers, which are also on the loop. Okay, so that's if you go that way. What happens if you go the other way? That would mean that you go starting from here. So this would be 1, which would be next to 7, next to 2, 8, 3, 9, and 4. This 4 would be next to a 9 here. So this would be 1 through 4 and 6 through 9 there. So you have going this way, 6 connects to 1. 1, 7, 2, 8, 3, 9, 4. So that forces this to be 9. You have 1, 2, or 3 here, 7, 8. 1, 2, 3, 7, 8. So this is 1, 2, 3. This digit then cannot be 3. It's 1, 2. So we are guaranteed that the high digits are 7. So 6 can never be here on this one because we know that the region number 6 does not match, is not on the loop because we only have 3 cells which are. So this cannot be 6. It's 7, 8, 9, 1, 2, 3, 7, 8, 9, 1, 2, 3, and 7, 8, 9. So obviously 7 is one of these 3 also. 7, 8, 9 would be next to 1 through 4. 6 through 9, it can't be 6 through 9. 1 through 7 through 9. 1 through 3. 7, 8, 9. 6, 7, 8, 9. Then we have 1 through 4. 7, 8, 9, 1 through 4. And then that would match the 6 through 9 here. It's possible this could be 4. Then that would guarantee 9's here and then 9 in another spot. Huh. Interesting. How many loop cells do we have then? It's 1 all the way to 8, right? So that's 36 loop cells. Interesting. So either way, the high digits are all 7, 8, 9. The low digit could be either 3 or 4. We're not sure which. Okay. So all of these have to be 7, 8, and 9. This sees at most 1, 2, 3, 4, 5, 6, 7, 8. So this is at most 8 here. And it must be part of a region. Interesting. Because, yeah. Yep, divide the filled cells into 9 orthogonally connected regions. That means this must be part of a region. So the one that's part of this region has to be either here or here, and that's N. Interesting. The cage. So this sees 7, 8, or 9 in the orthogonal space. Well, it can't be 9, right? That means it would see, well, actually it could be 9. If it goes like, say like that. That could actually work. Hmm. 7, always has 7, 8, 9, but it could have 1 through 4 in the low digits, possibly. So again, the 9 is always going to be 4, 9, 3, 8, 2, 7, 1, 6 in some order. So I don't think this can ever be 9. If this were a 9, it would see 9 cells in its region just from there. 9 loops, 9 region cells. And it cannot go this way, because then this would also see 9 region cells, right? So it must go some here. But how would that work, right? So it'd have to be something like that it sees as a region. Actually, we can stop coloring these, so... the region would have to be part here and part here. It can't be... This is 6 at most. So 7. So assuming this is 9. That would be 6, 7, 8, 9. So this is guaranteed to be part of its region. And this cannot be all 9, so this is guaranteed to be part of its region. So because of that, this must stay within its region. So then it would have to be 4, 3, 8, 2, 7. And this would be 1, which obviously doesn't work. So this can never be 9 here. So 9 is one of these two. How does that work if it's 8? So 8, this goes... Okay, so this is 1, 9. So if this is 9, 4, this has to be 9. If it's 1, this has to be in between 2 cells. So it's 7 or 3, 2, 8, 2, 8, 3, 7, 1, 9, and then this is 4 or 6. Which goes to 1, 9 here. So this would be 9, 1, 2, 3. 1, 2, 3. It cannot be 4, because this is the 9 then on that side. Otherwise, this can't be 1. So this is 1, 2, 3, 7, 8, 9. 1, 2, 3, 7, 8, 9. I think it's all 1, 2, 3, 7, 8, 9, right? So if this was 8, that's mean it would see at least 8 this way, 6 this way, so 2 at least this way. Um, and then it would have to be, I guess it could be the full 9 that way, right? Except that it can't be full 9 because 8 can't be the start of the loop, right? And it would have to be the start of the loop going this way. So it can't be a full 8 going that way, which means it does have to go here. I don't even know how it would connect to, yeah. Would be, one of these would be 7 or 9. How would it connect to both? I don't think it can. Right? Um, it would have to connect to both. It would be in the middle. So the loop would have to be something like this. And this is the minimum that I would get to. But then I don't even know how that would, like, you have 7 going this as the loop. It would have to see another one here, and then it could have another one here. So this would definitely guarantee have to be like this on the loop, at least. I guess it could be something like this, but then the problem is... Or it could be something like this, technically. Right? And then the other ones that it sees on the loop, 1, 2, 3, 4, 5, 6, 7, 8, would be non-loop cells in the region. So then the question is, could this actually get all the way down here? And the answer, I think, is no. If this is 9 and it connects this way, the problem is that... Yeah, it's just not going to... This then can't connect to this end of the loop, which it would need to. Because 7 and 9, again, 7 and 9 are both connected to 8 on the loop. So if we try to have the okay, so this, yeah, this is problematic because this has to essentially connect to here somehow without blocking out this region, and that's impossible. Because this one has to go through here to connect to here. I don't even think it can. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it can't even connect to here. So even that doesn't really work. So then this can't be 8. This has to be 7. Okay. So this has to be 7. These are 8 and 9. This 8 essentially has to connect to the 7 if this were 8. I think this has to be 9 then. So say this is 9 here. I mean, I guess it could connect that way. The problem is it would basically block out these regions, right? So then you'd have 8, 9, and then the 9 would not connect, would have to connect to the 2, and the 2 would somehow have to connect to the 3, and that's not possible, right, in this situation. So I think this has to be 8, and this has to be 9. Okay. There's another region here, which I guess we'll call light. And it must contain this digit. This will be medium. This will be pink. We'll make this green. So this is 7. So it could be at the end of one. But it can't be at the end that touches the 8, right? 8 is in the middle. So 9 has to be next to a 4. So one of these two is a 4. We don't know which. And the other one's a 3. So this is 4 and 3. This does not see 9 cells in its region. Okay, so this is 3 or 4. This can't be 4. If this is 4, how does it connect to the other 8 in the region? So this is definitely both dark or medium gray. Yeah, you can't connect to this. Can you? I don't know, maybe. With 8 being in the middle, no. How does it connect? 4, 9. I mean, it's 4, 9. 3, 8. Yeah, that doesn't work. So this has to be the 4, and this is the 3. I guess it doesn't have to connect to the 4 necessarily. Something must connect to the 4, though. It's very okay, so it's very likely this is 4. Then you have 9, 3, 8. And that does actually work decently. This must see at least 2, then. It can't be 8 or 9. So this is 2, 3, 4, 5, 6, 7 that it sees. So these are on the loop. This is 3 or 4. Since this is 3 or 4, 2 sort of has to be in this direction here. Okay. So the cages are at least 2. This could be pink, technically. It's pink or it's light, right? I mean, technically, it could be a completely different region also. This sees at most 3 cells. So this is 1, 2, or 3 here. This sees at most 1, 2, 3, 4, 5, 6. This sees at most 1, 2, 3, 4. And I don't really think it could ever be 4, right? This dark can never get to that region. 1, 2, 3, 4. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No. So this cannot be 4. This is 1, 2, or 3 at most. Oh, wait. That's loop cells. Apologies. So that could be 4. Oh, we know there's 1 because this is on the loop. Oh, it can't touch itself on the loop. So we know all of these cells are on the loop. There's too many coloring things I need to do. So this can't be 4 cells on the loop. It has to be at most 3, right? Because we know These both have to be on the loop for the 9K region to actually work. Okay, so these are on the loop. Obviously, this is on the loop. Okay, so this is... it's too many colors I need. I need too many colors. Okay. This is going to be a high. This is a high. It's on the loop. This is a high and that's on the... Oh, this has to be... The 8 must also be next to 2 digits on the loop. So these are also on the loop. This is obviously not on the loop. So this must go this way on the loop. This could go this way. Eight is next to 2 and 3 on the loop in the green region. Because 8, it has to stay within the region, right? And these can't be part of that region. So this is guaranteed 3 cells on the loop. 3 cells on the loop in that region. So this cannot be on the loop. Huh. This cannot go up. If it goes up, it would have to go out of the region to be on the loop. And it can't do that. Right, because this is the leftmost of the topmost row of that region. 2 and 3 has to go to something else, so it has to go here. Therefore, this is connecting to the loop. Therefore, this is part of region 9. So we know this is a border then, and it connects this way. So these are not on the loop. None of these can be on the loop. This can't be on the loop. These cannot be on the loop then. So this must be a 4. That must make this 9. To make that 3. To make that 8, 2. This must be 3. It connects to 8 on the loop. That means it connects to a 7. Next, 1, 6, and then it connects to, 9. So this is 9 then. We have 9 next to 3, next to 8 to 2, to 7 to 1 to 6. Which means the 7 has to be 1 next to 7, 8, 9. Next to 2 or 3, 2 or 3, 7, 8, 9, 7, 8, 9. But this can't be 7 here. Eight, so this is at least 3. This is on the loop, right? Arrows indicate number of loop cells. So this is 6 at most. It cannot be 3 because of the 3 in the row. So it's at least 4 cells on the loop. Interesting. This obviously sees at least 1 cell on the loop. We have 8, 2, 7, 1, 6. This sees at least 4 cells on the loop. So this is at least, it can't be 4. It's at least 5. And it sees 1, 2, 3, 4, 5, 6, 7, 8 at most. This is 5, 6, or 7 cells on the loop. So these are all on the loop. This sees 5, 6, or 7 then. Because it can't be 8 or 9 because of the 8 and 9 there. This can never be 3 because if it sees 3, these would all be on the loop, but we know this is on the loop. So this is a low. So if it goes... Oh, I guess it could be that way. That's possible. Hmm. So these are not... This is a boundary for that region. This is a boundary for that region. So for the 2 region, we have to have just 1, right? So say it went this way. So that would be 2, 7. I guess that's possible. Hmm. Huh. That means for the 2, so it connects from the 4 to the 9. So this must be 6 to the 1. Can the 4 actually ever be here? So 1, then we have 6, 7, 8, 9, 1, 2, 3, 4. No, so it has to be 3. Okay. So this is guaranteed to be 3. That means it must be with 8 or 9. So one of these must be 8 or 9 and be on the loop. Unlikely to be here, but it's possible. Right? You could go here, 8 and 9, and then 1. How would that connect? Okay, so yeah. I guess it could go all the way around here. Let's see. Say it went here, and this was the 9 that was in that region. You can't connect to here because then, well, okay, let's try going this way and then connecting here. So you have 1 here. You'd have to have 6 and then 1 again, which is not possible that way. I guess you could go try here. 1, 6, 1, 7, 2, and then 8, which is not connecting at all. So no, it can't. This then has to almost certainly go this way on the loop, which means this is at least 2. Actually, this can't be 2 because it can't connect this way and then go to anywhere else. So this is not on the loop. This is a 2. This is 8 or 9. This sees 2. So the region for 2 can never be here. The region number for 2 cannot be here. It could be here. Can it ever go 1 here? Okay, we have 2716, right? So 2716. That must connect to a 1 in the 2 region, which would connect to 8 and 9. So this cannot be 2716 here. Um, 2716. Then you have 1. That's possible. Or 2716, and then you can't touch itself. 2716, that could be 1. How does that work? This is part of the 2 region. I guess 2 could be here? Yeah, it's possible. This would see 7 cells. That would actually work. Um, hmm. Obviously, 2 could not be here. So if this is 2 and this is... sorry. 2 cannot be here if it goes down. So if we do 2716... You can't even do that, right? You can't go 2716, because that would force this to be 1. Can't touch itself on the loop. So you could go 2716 and then 161. That does work that way. Or this can never go down, 27161, because this would never be part of the loop. And in fact, actually, I don't think you could go 2, 7. You can't connect. It would be touching itself. So 161. It would be touching itself. And you'd have a repeat on the loop. So it actually has to go this way then. This is 2, 7, 1, 6, and 1 has to be here. So this is part of region 2. This is region 9. We don't actually know that's there. So this is on the loop. This is on the loop. This is not on the loop. So this is 5. And this is on the loop. Blue, red. This is not on the loop. Sorry, this is on the loop. And is another region. So we know that's done. This is at least 5. This is 2. These are not on the loop, obviously. These are not on the loop. We need 5 on the loop here. It has to go back somewhere here, so that's 1. So it could be 2 here on the loop. We need a 2 somewhere here. This is exactly 5 on the loop. This is likely region number 1. In fact, I think it sort of has to be, because if it's not, then this is problematic here, right? 1, 2, 3. So this is part of the region. Okay, so we know it has to go here. This is a digit, too. Can't be 1, 2, or 3, so it's at least 4. Could be 4, 5, 6, 7, or 9. Actually, it can't be 9. We can only have 8 other digits on the cell. So only 7 digits on the loop at most. This looks like it has to be 5. It can't go back here and then go back in. So this is 5. So this is 5, which could be part of the 9 cage. In fact, it probably is part of the 9 cage. It can't be part of the 3 cage. Or 3 region, sorry. Okay. 5 cannot be here. So this is definitely a border. Remember, we need, so this is, okay, so this is, 5 cannot be here. So this is definitely a border also. These can't be part of the loop. This one needs a 2, so one of these is 2. We know that for certain. You have 2 go into a 7. So 7, 1, 6, 1, 7 does work. 2, 7. So it can't be 2, 7, 1 here. 2, 7, 1, 6, 1. That does work. 2, 7, 1, 6, 1 potentially works. No, this can't. Okay, 2. If we try to go 2, 7, 1, 6, 1, that doesn't work because that would be above. That would be a row above this region, even though it must connect to that region. Yeah, this is almost certainly 1 here. If it's not 1 here, how is this region going to connect to the loop? It can't. It's blocked by the 8 region and the 7 region. So this has to be a 1 in one of these cells here. So this is the 2 region, this is the 3 region, this is the 1 region. This does see 7. So 1, 2, 3, 4, 5, 6, 7. 5. Where can 5 be? 5 could be here. 5 cannot be any of these. So this cannot be the last cell of the 9 region. So then these are all borders. Same with this. This is a border. This could be part of the 9 region. Or this could be 5. Or this could be 5 as part of the 9 region. That means this 2 region has to be going out here. And one of these is 2 as the region number. Okay. So it cannot be 1, 2, 3 here. It's 4. Okay, this can't be 6 because of 6 in the row. So it's 4, 5, 7, 8, 9 in that root cell. It can't be 2, 7 here. Because if it tries going 2, 7, how does this work? 1, 6, 1? But the problem is the 1 has to be part of the 7 in the region. So if it tries going that way, it has to go down that way. And then this will be 1, 6, and 1, which we repeat of 1 in that column. So it has to go down. So that's 7. It can't be 1 here, because that would be 1, 6, 1. And the 1 has to be part of the 7 region. can't be, could it be 161? It possibly could. No. Right, so if it tries going this way, it would be 161, but that's not part of the 7 region because it'd be too high. So it can't go this way because 161, the 1's too high and not part of the 7 region. 16 can't be 1 because of the same cell. It can't, 1's can't be in the same column. So this almost has to be 1. You can't go 1 because that's 6 and 1 forcing that way. So this has to be 1 going this way, and this is 4. And the loop has to get back here somewhere, so this can't be 6 here, which makes that a 6. So this is 6, therefore that's a 1, and that's 7 with it. So that's on the loop. Blue, red, blue, red, blue. It has to go down there. So these are not on the loop. These cannot be on the loop. These are part of that region. We need a 4 and a 5 remaining. 1 is here, so this cannot be 1 here. Which means this must be 1 as the region sum, or the region number. So this is part of the loop. Part of the loop. This sees, so... We have 4 and 5 remaining in region 8. We don't know where that is. You can have at most, so this is, we have remaining digits in row 1, could be 4 or 6. This can't be 6. This is guaranteed to be a 4 then. Because this must be part of a region to be orthogonally connected. And so this is 4. You could have a 6 here, but this cannot be part of a region. So this is just, yeah, this is blank. I guess we can mark it with zeros. So we can mark blanks with zeros, I guess. So this is definitely, it's not definitely blank. This is definitely blank, though. This is part of that region. It cannot be 1, 2, 4, 5, or 6. So this is 3, 7, 8, 9. Can't be 7 because of the... So can this ever see 8 cells in the region? I think the answer to that is no. So again, can't be 1, 2. These are part of its region, so it can't be 4, 5, can't be 6, can't be 7. Can it ever see 8 cells in the region? No, the answer to that is no, because this is region 8. And this is a region 1. So this has to see 3. So this is 3 here. This 2 region needs a 3. And therefore it has to go somewhere here, at least. This 8 region needs a 4. Okay, so we have 1, 2, 3, 4 at most. 5, 6, 7, 8, 9. So there's no way. So say we try to go without this being a region, in the region. If we tried that, it would be at most 1, 2, 3, 4, 5, 6, 7, 8, but then this would not see 3. It would see more than 3 cells. So this must be part of the region. Since this is part of the region, this cannot be, because that would connect all 4 of those, and this would see 4 cells. So this is not part of the region. It's 0. So it goes around here. This must see here, and then it must see this one. So these are So it must go down there, and then it blocks here. Because this must see these 3 cells. This is blocked as a region. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this has to be the region here. There's no other space for it. So this must be a 6 here. So since this is a 6, this is not a cell. That's 0. So this could be region 5 technically. Unlikely, but possible. The rest of digits in this region 1 are 2, 7, 8, 9. But this can't be 2 or 8 or 9. 2 has to be this region number here. This must be then 7. This can't be 2 or 7. It's 8 or 9. And this can't be 7. So this is 2, 8, and 9. And we have an 8, 9 here. So we have a 2, 8, 9 triplet in row 4. Interesting. Okay, so this is what, 2 or 3, and this is 8 or 9 here. Oh, 7's next to 2. It can not be next to 3. So this is 2, which means this can't be 2, which forces this to be a 2 here. And this is an 8, 9 pair. Okay, so this is 1 through 6 here. So this is a region boundary here. I guess we don't need the 0 there anymore. We can have at most 2 cells here. So this is 8, 9. So it either turns here and then goes this way, or turns here and goes that way. Because this has to be the other 8 and 9 for the 7 cells on the loop. This so far sees... This is not on the loop. 1, 2, 3, 4, 5 could be on the loop. So up to 5. Let's see. Hmm. This sees at least 2 here. So this is not 1. Interesting. If it goes this way, this would see 3, and then it would be 8, 9. and then it would see no other cell in the region, so it would have to go that way. Hmm. Oh, can't go this way because of the 3 in the column. So it must go this way. So this is a 3. Therefore, it sees 8 and 9. It could go this way. So this is not on the loop. It can't ever enter in here and exit out without touching itself, so these are no longer possible on the loop. It could just go straight through. This can't be 3 anymore. This can't be 3 because of the 3 in the column also, actually. So there's only 1 or 2 cells on the loop here. You could have 8, 9 here. Then region 4 would have to be here. No, region 6. And it would be 1, 2, 3, or 4 there. So if it goes 8, 9 here, it would have to turn here. If it goes 8, 9 here, it would also have to turn here. Oh, so this is not part of that region. Because this sees only 3 cells in its region. And it would be 1, 2, 3, or 1, 2, 3. So this is not part of its region, which means this is not part of the region, so this is blocked that way. You don't know if it's 0, though. It could be technically part of some other region. So going 8, 9, 8, 9, it cannot go down? Yes, it cannot go down. Well, it couldn't anyways. It would have to go here because it turns here because this only sees 3 cells in its region and it would be 1, 2, 3 or 1, 2, 3. So then it would always go here. So this is always low. So this is 3 or 4. Okay. The 6 would need to be one of these digits this way. Could not be either of these for that region. So it could go one of these two. That means if it goes this way, it can't go in here and back out. So these are not part of the region of the loop. Could exit out that way. Could technically do this, so that's possible. Oh wait, this is only one, right? It had to go here and then turn, or here and then turn. We see 5 cells now, so the rest of the cells cannot be on the loop. Therefore, it goes this way. So this is 8 or 9. It's part of region 7, so that means it blocks here. We don't know if this is part of another region. This has to be blocked that way because it cannot see any other cells in the region. This actually has to go this way, so that's blocked also. So this is a digit, and it sees 5. It has to be 5. It can't be 8 or 9. 1, 2, 3, 4, 6, 7. So this is 5 and part of another region. So this sees 5 cells. It could be just seeing 5 cells that way. It sees at most 1, 2. So therefore, these have to be filled. So okay, so this one must go out this way to be on the loop. It has to be 8 or 9. Oh, it cannot be 4 here then. That makes this 3. Because it's next to 2 unique digits on the loop. Because it cannot go any other way here because this 5 limits it. That's how many digits how many loop cells it sees. So none of these can be loop cells. So this must be 3 with 8 and 9 there. This has to be a digit. It sees these sees 5 at least. So these two have to be digits. This can't be 1, 2, 3. So it could be 4, 6, and 9 here. This could be many things here. So this could be 1, 2, no 3, 4, no 5, no 6, 7, 8, and 9. This could also be part of the loop, so that's fine too. Okay. Ah, this cannot go this way. If it goes this way, the problem is 3 can only be next to 8 and 9 on the loop. And it can't be 8. This cell can't be 8 or 9 because of the 8, 9 pair in the row. So this has to go this way. So this goes this way is 8 and 9 is not part of the region. Because 3 only has 2 cells on the region in the loop. So this is region 4. Interesting. So the 4 in this region must be one of these cells. Huh. Okay. Hmm. Doesn't this almost certainly have to be a 4 here? 1, 2, 3. How do you get 7? 1, 2, 3, 4, 5, 6, 7. So, okay, there's 36 cells in the loop. We know because we have n minus 1 for each region. So we have, right now, this is 6. We have 7 here. This is 8. So that's 21, 22, 24. So 12 more. So if we tried to go right, set 6, 7, 8 is 21, plus 1 and 2 is 24. We already have 2 here. This is a third. So this can't be 2. This has to be at least 4. Interesting. So one of these two at least is set. So can this ever be 7 is kind of a question, right? 1, 2, so we have 24 in these digits. We have an extra 3 here. So it's 27. We have an extra 9 to work with. So 1, 2, 3, 4, 5. That kind of works. 6, 7, 8, 9. Actually, that does work. Interesting. Can it go down? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, it could do that. Can it go something like that? I don't think so, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. No. So if it tried to go this way, it can't. So none of these can be on the loop, right? If it tries to go here, 1, 2, 1, 2, 3. Oh, wait, no. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it can go 1 this way. Okay, so this is not on the loop. This is not on the loop. Can it go... It can't go 2 this way, right? 1, 2... So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Nope, too many digits. So it could go 1 this way. So it can never get any more here anymore. But it could go 1 this way. It can't enter in here anymore because they would go here, then enter in, and then it would be touching itself, exiting out. So that's not possible. Okay, this 8 eliminates 8 here, so this must be 9. This 7 region needs access to a 4, 5, and a 6. 5 obviously can't be here. 5 couldn't be here. Oh, this sees 7 cells. Well, it doesn't see these 2, so it must see the other 7 either here or here. Huh. It could see all of them there. Interesting. How many? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is not a cell. So it must see something here, at least. So 1, 2, 3, 4, 6, 7, 8. It's possible. So those are possible. This is a 0. This is 0. So this is blocked. This could be 4, 5, 6 here, technically. This digit cannot be 1, 4, 7, or 9. So it's 2, 3, 5, 6, or 8. This can't be 2, 6, 1, or 7. So it's 3, 4, 5, 8, and 9 as possibilities. This sees 4 cells in this region. This sees 1, 2, 3, 4, 5, 6, 7 cells in this region. This sees 4. This sees 4. This sees 4. This sees 3. This sees 1, 2, 3, 4, 5. This sees 3. And this sees 5. So that region's fine. This sees 7. Okay, so this has to be seeing 7. So this is blocked off in that region. So it's either 7. So it sees 1, 2, 3, 4, 5, 6, 7. So that's fine. So this is blocked off that region. Ah, well, no. That sees... all of these see 5. So that's fine. This sees 3. This sees 3 or 4. This sees 3. This sees either 2 or 3. So that's fine. So the only way this is part of another region is it's part of region 5. Is that even possible? None of these are on the loop. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Or 7, 8, 9. 6. You need No, in region 5, you need 4 cells in the region. So already, no. This cannot be part of a different region. It can't be part of region 3. It must be part of region 9. So this is guaranteed to be region 9. So that's done. And this 5 sees only 2 cells here. So that's done. Region 3 cannot go here, but technically this could be part of another region. Okay. So at least one of these cells must be part of a region. So if it tries going this way, it would have to go up here to do that, which is not possible. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So then it cannot go back. If it tried going back, that just doesn't work. Actually, yeah, if we try to go 7 here, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, it has to go back here to force this to be on the loop. So this cannot be 7. Can it be 5? I mean, technically it could do something like that. Does that even work? I guess it could do something like that. But that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it can't do that either. What happens if it goes that way? So 1, 2, 3, 4, 5, 6, 7, 8, and 9. That does actually kind of work there. Can this ever be 4 or 5? Can it ever be 5 is kind of the question here. I think the answer to that is no. Right, so these would both be highs. And I guess it could do something like that, but then it has to loop back because you have to have something on the loop there. So maybe that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, it's just too many. Because again, we know exactly how many digits are on the loop. We have the count. It can't do this because it still needs to loop back. And that's still too many. 1, 2, 3, 4, 5, 6, 7, 8, 9 already. That's too many. So I don't think this can ever be 5. I think this has to be 4 then. So this is 4, which means one of these two is on the loop. This cannot be 4. Um... 5. 6, 7, 8, 9. So that's possible for 5. What about 4? 4, you cannot exit and then come back. So 4 has to be something like that. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's possible. Right, so if you had 4, you can't exit out this way and then come back. You could do something like that, actually, though. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so you can't actually go this way. Say you tried to go here. The problem is you have to go back up here to be in that set. Oh, this is 5. 1, 2, 3, 5. And we know then this must be 4. So 1 digit here. This is not on the loop. Because we have 5 already. Sorry, we have 4 already on the loop, and we need another one for this 4. But this one doesn't see that cell. So can it actually go back here? Is the question. Actually, can we have 4? Yes, we can, right? Or actually, it would have to be 1, 2, 3, 4, 5, 6, 7, 8, 9. It needs 9. Oh, you have to go here, too. Well, can you ever have 2? Is the kind of the question, right? For 5, you need that. For 4, you can't exit out. Well, that's too many cells. 1, 2, 3, 4, 5, 6, 7, 8, 9. You can't enter in and exit off immediately. So it would have to be 4. You have to go this way. And you need 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, because this is 27 here. Right, 5, 10, 13, 16, 19, 21, 22, 24, 27. We already have 27 cells on the loop. Hmm. Huh. 4 cannot be here or here. This is not part of region 2. So it cannot go here. It could technically go here. If 2 goes something like that. The 2 has to go down at least twice because it needs access to a 3. This 4 region has to go somewhere up here. It could do something like that, and the 2 region goes like that. That's possible. Huh. Okay, so 4, it cannot exit out, enter in, and go back that way. There's too many cells. So for 4, it has to go straight down. It must go this way to connect to get to this cell. So this is always on the loop. You can't just do this. Actually, maybe it could do this. No, it can't because it needs something here too. So if it tried to, I guess 1, 2, 3, 4, 5, 6, 7, 8, 9. It's too many. 10, 11. So if it's 4, it has to essentially do like that. If we try, well, 3, yeah, it has to exit out. It can't, 1, 2, 3, it can't. It's too many. 1, 2, 3, it has to enter here. 4, 5, 6, 7's too few, so it has to be 5, 6, 7, 8, 9. So this is for 4. For 5, it could go 1, 2, 3, 4, 5, 6, 7, 8, 9. And that would work. So I think those are the only 2 options, right? Either way, I think this has to be 1. High, low, high, low. So that does actually work to be on the loop, possibly. Okay. So the possibilities are here, connecting here, down here. So that's a possibility. Or we go out, we connect here to here for 5 to here. So this is the other option, which means either way, this is a 1. Right? It sees 1 here. Actually, can it ever be this way? Then that would have to be 3, 8, 9, 1, 2, 7, 1, 2, 6. I guess that's possible. Huh. So either way, this is 1 guaranteed. We know these are on the loop, so this must be a high. Yeah, we can remove pink. This is definitely a high, and this is definitely a low. So that would be high, low, high, low, high. So this is high. So it has to be a 7, right? Or it's 6. It possibly could be 6. 1, 2, 3, 4, 5. So that's in 6. It could technically be 6. No. If it's this one, it's in between 2 unique digits on a German whisper line. If it's here, it's also between 2 unique digits on a German whisper line. So either way, this is 7. Okay. This cannot be 9 or 8. This is 6 or 7. This cannot be 2 or 3. It's next to 6 or 7, so it can't be 4. That makes this a 1. So this is 1. If we tried going this way, the problem is this would be 4, so that's 3 in the loop. Therefore, these would be also part of the same loop, which is not possible. So it cannot go pink. So it has to go green. So the green is the correct one. So this is blue, red, blue, red, blue, red, blue, red, and blue. Okay. That means this is a 1-2 pair to be next to 7 on the German whisper line. This has to be 6, 7, or 8. So these are, we have already 6 in this 7. So we need 1, 2, 3, 4, 5. So this is an edge of a border. This can't be 6 because 6 can't be between 2 unique digits on the German whisper loop. Same here. This can't be 4. It can't be 3. This is a 1-2 pair. So this is 7 or 8. This is 8 or 9. This is 7. This is a 1-2 pair, which eliminates 1 and 2 in the rest of the column. This has to be 6 or 8 here. Because it cannot be... This is 6 or 7. That means this can't be 1 or 3. This has to be 2. That forces this to be 7. So these are all in the same region. So that's a border. This is region 5 then. So this is region 4. This is region 5. This is already 1, so this can't be 1. This is 2. That forces this to be 8, because 2 cannot be next to 6 on a German whisper line. This 2 eliminates 2 here, so it's 1, which makes that 2. This can no longer be 8. It sees 3, 5, or 6 in the same region. So these are not, this could be part of region 4. This is not part of region 4. This is region 5. So this can never be part of region 5. This is part of 6. What region can this be then? I think this has to be... I guess this could be region 3 here, right? This one, though, I guess it could... The 3 could be part of region 3 that way also. Okay, so all the arrows should be right. This is 5, points to 5 that way, and 5 that way. This is 5, points to 5 that way, and 5 this way. So this is not... none of these... Yeah. The rest of this is not on the loop. Okay, we're going to mark... I guess we'll mark it as gray. We're doing okay already with the borders. This sees... Oh, so this must... These are all the same region. So this must be 5 that way. So this is a border here, and this is a border here. Because this must be 5 in region 6. The 6... So we have 1, 2, 3, 4, 5. We have a 6th here. This can't be 6 because this is all region 6 now. We know that for certain. We need access to a 6, and it has to be either here or here. It can't be here. Right, where is the 6 going to be then in this region? Can never be here. This is already 7 cells. So we need 8 and 9. So it's one of these two is a 6. We don't know which. This 8 eliminates 8 here. Okay. This sees 7. It's not the same region as this one. 4, 5, 6, 7. It could potentially go that way. If it goes this way, this is a 4. This would have to be 5, and that would be 6. Or this could be 4, 5, 6 this way. That's fine, too. So we have the loop completely done. We just have to get the regions now. This is 5 cells on the loop, 5 cells on the loop, 5 cells on the loop, 5 cells on the loop. 4 cells on the loop this way, 2 cells on the loop this way. This is a 4 because it points to 1, 2, 3, 4 cells on the loop. This points to 1 cell on the loop. I think those are all the arrows. So this can't be 4 here. This 4 region... Oh, this is a 5 region. It needs a 5 somewhere to the left of it here or above it. This 4 region needs a 4 to the left of it or above. 4 cannot be here. This is part of the 2 region because the 2 region has to go out somewhere. This can't be 2, so this must be the 2 here. So this is part of the 2 region here. You could have a 6 here, technically. That's fine. 4 again cannot be here. This is not part of the 4 region. 4 cannot be here. So 4 can't be here, 4 can't be here. Where is the 4 in this 4 region? It must be here or here. We don't know. The 6 has to be one of those two because it can't be either of these. And it can't just go here. This technically could go here and then here. That's possible, so that's why we can't block that off. Let's see. We're getting close to solving it, which is good. I don't think I need another video for this. This is very hard. But it's not... The logic is not that hard, I would say. It's just thinking of it through things take a while, right? Five region has 4 digits already on the loop. This could be part of region 4. It could be part of region 3. It could technically be part of region 5. It cannot be part of region 6, 1, 8, 9. 9's all done. 8, we need access to a 4 and a... Oh. Interesting. This 8 region needs access to a 4 also. I guess it could go down, technically, right? It needs access to a 4 and a 5. So it can't go down more than once. Okay, let's draw the actual loop so that we can actually start using colors to actually signify other things. So this is the loop. We can clear the colors. We know this is the light region. We're going to make this pink again. This pink, this will make dark. Or I guess we can make it... Yeah, we can make this medium, which is more fitting. It's 8 and 9, right? This will make green. We'll make this red. This... Guess we'll make this yellow. We'll make 4 blue and 3 orange. And then pink can be the 2 in the middle. Okay. We need access, so the 8 region has 2 that it can be, so it could be potentially here. It cannot be 2 cells here, but it could be 2 cells here, 2 cells that way, 2 cells that way, 2 cells that way. It cannot be both 2 cells that way because one of them has to be 4. So, okay, so that can't... Could be 2 cells that way. That's fine. 5. No, this can't be... That can't work. So it's either 2 cells here, 2 cells here. I don't think it could be 2 cells this way because that would have to be both 4. So this is not possible because it can't be 2 cells that way, can't be 2 cells that way. Green can go up to 3 that way or 3 that way. It has to be those sets. Red has to go at least 1 this way. So this is definitely red. Okay, this is guaranteed to be red. So this has to be not 1, 2, 3, or 5, or 4. So no 1, 2, 3. So this is 6, 8, or 9 here. And it must be red. Guaranteed. Pink has to be, so only one of these could be pink. Um, this yellow needs access to a 5. It could be here. It could technically be here too. This cannot be gray, cannot be green, cannot be red. Could it be blue? I guess? Maybe? No. If it's blue, it's part of 4. It can't reach 2. Well, 2 already has a 4. So I think this has to be yellow. Can't be part of 3 because you can't go this way on the 3. The 3 is blocked off from this region there. This is not yellow. This can't be blue or yellow. It can't reach red. It can't reach pink. This has to be part of orange. So this is definitely part of orange. This can't be yellow, can't be red. It's either blue or orange here. We don't know which. This is either part of blue or orange. Technically, it could be part of yellow, but no. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, it can't be part of. Yeah. Can this actually be blue? 1, 2. Okay, this is blue or orange also. 1, 2, 3, 4, 5, 6, 7, 8, 9. No. So to avoid this one, 1, 2, 3, 4, 5, 6, 7, 8, 9. Even though we know this is orange. So the answer to that is no, this can't be blue. 2, 3, 4, 5, 6, 7, 8, 9. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's 10. Yes, so this is orange. Can this be blue? 1, 2, 3, 4. Oh, no, it can't be blue because we already have a 2 in blue. So this is orange. This cannot be 3 because it's in the orange region. It cannot be 9. It doesn't see these 3. So this is 4 or 5. So right now it does not see 1, 2, and 3. Okay. This cell cannot be green, cannot be gray, it's blue or yellow. It can't be red because the red has already 8 cells in it. So red can be 1 cell extended here, 1 cell extended here. So this is 0. Yellow can go a lot of ways. Blue can go a lot of ways. Orange is actually now kind of limited. 1, 2, 3, 4, 5, 6, 7, 8. So we're trying to avoid this cell being part of the region. 4, 5, 6, 7, 8, 9, 10. It's too large. So if this is not part of the region, it essentially has to connect that way. That's 1, 2, 3, 4, 5, 6, 7, 8. But the problem is this would not see 4 or 5 cells. So this has to be part of that region. So we have 3 there already. Could be like that, right? So 1, 2, 3, 4, 5, 6. Okay, so this is blocked off blue. At most. So this is at, well, it could go here. Pink needs access. Okay, so I could access that way. Pink could get 5 more here. So 1, 2, 3, 4, 5. 3, 4, 5. So all of these up to here. Oh, this could be pink also. So all of these up to here could be pink. Technically, this could be pink also. Blue could be essentially go up to here. Technically, it could go to here or here. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it could. Yellow could go. We have 4. So red is done. Blue could access. We have 1, 2, 3, 4, 5, 6, 7, 8. No, okay, so this is not that helpful. It's really this area that's we're more interested in. But even that's not too helpful. I don't know. I think it's helpful for the grays and the greens to see where they could be. But I think everything else isn't that helpful. This could be pink. Hmm. So there needs to be a 4. In one of the gray regions. So and a 5. So there's a 4 in one of these regions too. And a 5 cannot be here, could be here. There's also another 4 we need access to, but it could be one of these 3 also. Okay, so okay. This orange needs access to a 1. Huh. Okay. We already checked the 1 region, that's kosher. We checked the 9 region for cage cells, the negative constraint, that's kosher. This sees 2, at least. Sees 2, 3, 4, or 5. This sees 7. This sees 3. This sees at least 3, and it could be 4, 5, or 6. Oh. It cannot go this way. If it goes this way, this would well, 6 could be here. Okay. So if this is 4, 5, 6, 6 cannot be either of these 2 cells. So this would be 4 or 6, but then the problem is this could never be 6. Right? If this is 6, that would see 6 cells in this region, which is not allowed because it's not caged. So this would be 4. This could not be 6, so this would be 5, and that would be 6 there, if that's the case. Because this would have to see cannot see exactly 6, so it would have to see that cell, and then these cells, that would be 7. This would see 6 cells here. This would see 6 cells here. If it's 4, 5, 6 this way, we have a problem. You're guaranteed to see only 5 cells here then, for each of these cells. So this cannot, and one of them would have to be 5, obviously. So this cannot be the green. Therefore, the green goes this way. This is 6, this is 4, that's 5. This 4 eliminates 4 here, so it's 9, which means this can't be 9, that's 8. This can't be 8 or 9, it's 6. So it cannot go here. We need access to, this 8 eliminates 8 here, so that's 7. We need access to a 4. And neither of these could be 4. This is the leftmost digit of the top row. This can't be 4. So 4 has to be one of these 3 digits. So this is border here. Guaranteed. Because none of these can be 4. So 4 has to be one of these 3. We're not sure which. So this is done as a border. This 8 eliminates 8 here, so this is 9, which makes this 8. This 9 eliminates 9 here, so it's 8, which makes that 9. This cannot be 4, 5, or 6, so this is empty. Therefore, this is a border there. Okay. This can't be 8 because of the 8 in the row. Okay, so this is done as a border. This, okay, so let's just go through to check the region 1, 7, and 9. Interesting. We could probably also check 6 too. 1, these 3 cells see only 4 cells. This sees 7. This sees 4. This sees 5 cells. This sees 5 cells. This sees 3. This sees 3. So that's done. This sees 2. This sees 6. These see 5. This sees 7. This sees 3. This sees 3. This sees 4. Sorry. This sees 3. This sees 2. So we don't have any cages around those. That's satisfied that. We have a cage here. It does see 7. This sees 3, and it's a cage around here. This sees 2, no cage. These see 6, and there's no cage. This sees 7. This sees 7, and there's no cage. This sees 3, and there's no cage. This sees 3. This sees 3 or 4. This sees 4 at least. If there was a 4 here, it would see specifically 4 cells only. So this cannot be the 4. If this were the cells, one of these, okay, this can't be 4. So this can't be the cell, therefore that forces this to be a 4 here, which means we can't have a 4 in any of the remaining column. So this is done as a region here. We don't need the 0 anymore. We need access to a 4 for this medium gray region. The only place it can access, because it's 2 cells, remember, is here. So this is a 4. Why can't that be 5? That could also be 5, actually. So one of these is, okay, so can't reach this anymore. So one of these 4 is a 5. This can't be 5. This is 0. So this is not a cell. These are done, so that's fine. This is blocked off as a region. So let's look at the 6 region. These sees 5, and this is cage, so that's fine. This sees 3, that's fine. This sees 4. This sees 5, 6, 7, that's fine. This sees 1, 2, 3, 4, that's fine. This sees 3, that's fine. This sees 6, 7, that's fine. So the region 6 is done. Region 7's done. Region 1's done. Region 9 is done. So this blue can only go to one of these two as the 4. 4 can no longer be here, here, or here. So it must be one of these two to make that the 4 region. So it can't go around that way, so it has to go up here always. So this is always blue. What cell digits can that be? No 1, 2, no 3. It could be 4, could be 5, no 6, 7. It could be 8. Okay. You're guaranteed a 5 here. That means 5 cannot be here. We need a 5 somewhere also here for this yellow region, but we don't know where that is. This is not a cell because it's not part of a region. We just need it for the orange to see what the boundaries of the orange could be. Huh. Okay, what about region 8? This sees 3 cells. Oh, this sees currently 3 cells. It doesn't have a cage, so it has to see more than that. So it must see that cell there. So this is a 5, which means none of these cells are part of that region. Okay. So this sees 4 cells now. This sees 3 cells. This sees 7 cells. This sees 6 cells. This sees 5 cells. 5 cells here. This sees 2. This sees 6. So 8 is done as a region. Pink could go something like that. We don't know. This can't be 5 anymore. This goes, we have 1, 2, 3, 4, 5, 6, 7 cells already. So it could be 2 here. It has to go. Can it ever avoid this cell? I think the answer to that is no, right? It can go at most 2 cells here, then it has to go down. It can only go 1 cell here, and then it can't go down anymore because the blue, it needs access to it. So it could go here, then here. It goes here, then here. So this is always pink. We know that's always pink. It cannot be. What digits can't be? It can't be 1. So this is 3, 5, or 6. It can't be 3. So this is 5 or 6. Okay. Can this ever be pink? Think so? Yes. One of these 2 cells has to be pink. Because right now this sees 2 cells in its own region. If neither of them are pink, then that doesn't work. Right? So this would only see 2 cells, period. So one of these 2 cells is pink. Probably this one, right? It could still be pink 1, 2, 3, 4, 5, 6, 7, 8, and we have a 9th cell somewhere. Yellow needs a 5 somewhere. And it could be any of these or up to here. So when it needs a 5, it can access any of those. Actually, it could technically be here too. It needs somewhere to the left of the topmost cell or above somewhere. And none of these can be 5 because of the 5 in the column. So yellow can never actually reach here. Pink, 1, 2, 3, blue could reach here actually. Okay. Oh, this is a cell in the region. Guaranteed. What digits can it be? No 1, 2, it could be 3. No 4, it could be 5. No 6, 7, it could be 8 or 9. Can't be 3 because we know the orange region already has a 3. I think we have all the 2s. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have all the 2s. We have 8 ones, I believe. 1, 2, 3, 4, 5, 6, 7, 8. Yes. 3s, we don't have that many. Again, pink needs access to a 3. Orange already has 1, 2, 3, 4, 5, 6. You can only access 3 more. It's not too helpful. Let's see. So yeah, pink's all done. Interesting. If orange goes this way, it must extend that way, right? Because then this doesn't have a cage. So we have the same problem there. So we've finished 1, 6, 7, 8, and 9 as regions. We still need 2, 3, 4, and 5. So 3, if it does go this, so it connects either here or here. If it connects here, it must include that, right? So that's 1, 2, 3, 4, 5, 6, 7. Then it must be, oh, this 9 eliminates 9 here, so this is an 8. That eliminates 8 from the rest of the orange region. Interesting. Right, so 1, 2, 3, 4, 5, 6, 7, 8, and then it has to connect, so one of these would be 9. Is that possible? So then this would be 5, right? This is we guarantee see one of, okay, so guarantee see one of these. So it'd be 5 here. This would be 9 then. We'd be missing a 1, so the 1 would have to be here. And then we'd be missing 6, 6, which would have to be then here. And 4, which would have to be here. That's interesting. Or it could connect this way. Okay. Hmm. The yellow needs access to 3, 5, 6, and 9. Hmm. Uh, we don't have that much information there. Pink needs access to an 8 also. So pink needs access to a 3 and an 8. Interesting. That means it needs at least 2 cells here. Because that's the furthest it can go without accessing. Okay, it needs to... 8 cannot be here. I guess technically it could be a 3 pink there and another pink there. That's possible. We need at least 2 pinks here. So 2, 3, 4, 5, 6, 7. We need a connection. 8. So we have at most one other pink. Aside from the 3 and the 8 here. Interesting. Oh, this pink cannot go here. This would only be 7, 9 as a possibility here. Right? So if it tried going this way, the problem is this would have to be a 7, 9 because of the digits remaining in row 3. But it could not be 7, 9 because of the digits remaining in column 6. So this is not a digit. So the pink has to connect that way. Since the pink connects this way, this has to be the 4 possible for the blue region, which means it's the leftmost of the top region. So this must be blocked that way. This can no longer be 4. So this is blocked as a region. This is blocked as a region. So we have 1, 2, 3. Okay, so this, if this were, well, 6 could go there technically. This is not part of the pink region. Because if it is, it's 6, and then this would see 1, 2, 3, 4 cells exactly, which is not possible. So this is not part of the region. So this is definitely blocked. So this is 0. This could still be a 6, though. Blue could still be here. This could still be pink. We have 1, 2, 3, 4, 5, 6 guaranteed. We have a guaranteed 7 and 8. We need another digit somewhere. This could go down to here as 3. That's fine. What digit is this? No 1, 2, 3, 4. No 7, 8, 9. So it's 5, 6. So it cannot go all the way down here as pink. This is a 5, 6, 5, 6 pair, which eliminates 5 and 6 in the rest of the box. Or the rest of the row. And the region. So we need access to a 7. So this can't be pink then. So this is blocked. This is done. This sees 3 cells. This sees 3 cells. This sees 5. This sees 3 cells. So that's all good. There's only 1 and 4 allowed in row 4. So this cannot be pink then. So this is blocked as a region. This pink goes then down here. But it cannot be 5 or 6. The only possibilities left is a 3. So this is a 3, which means this can't be 3. This is 5 or 6. And it cannot be pink because we already have a 5 or 6 in the pink. So then the pink has to continue out that way. So this can't be 5. So 5 for region yellow has to be one of these 4. So we have 1, 2, 3, 4, 5, 6, 7, 8. This can't be 7 or 9, therefore it's 8. We need access to a 7 or 9. So it cannot go down, cannot go up. It has to go that way. So this is the final pink one, which is 7 or 9. So this is done as a region. So this is 7 or 9 here. 5, 6, 5, 6. Okay. Can this blue ever go here? I guess so, if yellow's there. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, we do have access to that. Okay, the 2 regions done. Um, okay, so we don't need this anymore. This sees 3 cells. These say 3 cells. This sees 5. This sees 4. This sees 3. This sees 4. This sees 3. And this sees 3. So those are all satisfied too. Both of these cannot be blue, because then this would see 4 cells and it would be not allowed to, because it's no cage around it. Okay. Uh, Yellow needs 3, 5, 6, and 9. 3 cannot be here, cannot be here, cannot be here, cannot be here. Interesting. Okay. Say this was blue. That's interesting. It would have to see 5 or 6 cells. Well, then all of these would be blue. Right? Because it would have to see at least 5 or 6 cells. We'd see 1, 2, 3, 4, 5, 6, 7. This would then have to be the yellow and would be the 5. So that would be the leftmost cell of the topmost row. So this could not, well, that we don't have the guaranteed 5. Then the remaining digits in this would be 5, which would force this to be 4. That would only see 1 cell, so this could not be double orange then, because then that would force one. What you know, it connects to this one here in one of these 2 cells. It can't go around and connect that way. So then this is not. This would connect this way. One of these 2 would connect. Oh. Okay, well, that's one thing. So this is 9, which means this can't be 9. This is 7, which forces this not to be 7, so that's 9. Okay. The only possibility remaining in... So again, if this is blue, that means this has to see at least 4 blues here, and then either both of these or another one. That would mean this would have to be a 5 as yellow, which means that would be 4. This would not connect, so this would be orange. It would be the last digit. So that would have to be 5, which would force us to be 9. So that's okay so far. 1, 2, 3, 4, 5, 6, 7. Neither of these could be, so we need 1 and 6 in the orange. This could not be 1 or 6, so this would have to be the orange. And that would be 6. We need access to a 1, so it could still be that one. So the yellow region would have a border here. We need a 3, a 6, and a 9 for the yellow. This can't be 3, 6. It could be 9, though. We need access to a 6 somewhere. So then it can't be here, can't be any of these, because of the 6s in the row. So it would have to either be one of these two. So one of these two would be a 6 to be accessed. So this one has to be yellow to connect. 4, 5, 6, 7. It cannot be 3, 6, or 9. So therefore this cannot be blue. Because this yellow doesn't fill that scenario. Okay. So that's good. That means this is not blue, this is yellow. It connects to 4 here, and one of these two must be yellow. If this is 5, it cannot go this way. It would have to be here. Okay, so since this is yellow, how many cells can this be? 1, 2, 3, 4, 5, 6, 7, 8. That forces this to be a blue. So this is guaranteed to be blue, right? This is 8 at most without this cell. So this is guaranteed to be blue. The yellow cannot ever go here, right? If it goes here, this would it cannot be 5 because 5 has to be in the leftmost cell of the topmost row. So this would be 3, 6, or 9. So this is definitely not yellow. So yellow cannot go this way. This would also be 3, 6, or 9, so this can't be yellow either. So this is bounded that way. This goes here, so this can't be 5 anymore. So 5 is one of these 3. Since 5 is one of these 3, okay, this can't be 5. 5 has to be one of these 2 as the leftmost cell in the topmost row. This can't be 5, then this is 9. Okay. So if this is 6, then this would be 5. And one of these would have to be, these would both have to be yellow. If this is 5, it can no longer have 2 more here. So this would also still have to be yellow. So either way, this is yellow. So if this is 6, that forces 5 to be there. There's no more to the left of 5 because 5 is in the leftmost cell of the topmost row of the region. So for it to be 6, this would have to be yellow. If this is 5, we'd see only 4 here. You can't have anything to the left of it in the region. So we know, okay, we know this is 0. So either way, this must be yellow. And it cannot be 3 or 9. Therefore, it must be, it can't be 5. So no 3, 9, no 1, 2, 4, 7, 8. So it has to be 6. So this is 6, which forces this to be 5. That 5 eliminates 5 here, so it's 6 and 5 there. We don't need a 0 there. these are no longer part of the region. So we have definitely here. We need 3 and 9. And then 9 has to be one of these two. And so 9 is one of these two. We need a 3. 3 can't be here, so 3 cannot be here. So 3 is one of these two, cannot be here, so this must be 3 here. So this is done. We don't know where the 9 is. It's one of these two. Okay. What do these cells see? This sees 5 and it's caged, so that's good. This sees 3. This sees 4 or maybe 5, that's fine. This sees 1, 2, 3, 4, 5, 6, or maybe 7, that's fine. This sees 4, that's fine. If the 9 goes here, okay, so this is boundary this way. If the 9 goes here, this would see 1, 2, 3, 4, so this cannot be the 9. So this must be the 9 here, and is done. So these, we have the boundary there. So again, this 5 sees 5, that's fine. This 6 sees 3, that's good, with no cage. This 1 sees 5, with no cage. This 8 sees 7, with no cage. This 3 sees 5, with no cage. 9 sees 4. 4 sees 3. 2 sees 5. 7 sees 4. So that's done. Blue has to go out this way. Okay. Blue needs access to a what? A 3, a 5, a 6, and an 8. Okay. This cannot be a digit. Because all the digits are already in it. 1, 2, 3, 4, 5, 6, 9, and 7, 8. So this is not a cell. Okay, so this is, we have boundary, boundary. Same here. This can't be a cell because we need 7 and 8 remaining in the column, in column 7, and this that's eliminated by here. This could be an 8. This needs access to an 8, and it cannot have an 8 here or an 8 here. So it must access either 8 here, so it'd be 1, 2, 3, 8 here. So it needs to access an 8 either here or here. This would be guaranteed 1, 2, 3, 4, 5, 6, 7, 8. So we need, again, 3, 5, 6, and 8. This can only go down 2 at most. So this has to go out here because it can't go this way. So this is guaranteed to go that way. So this is a boundary also. We don't need the 0 there then. This can't be 8. So the 8 has to either go to here or to here. So we have 6 already in the blue region. This can't be 3 or 8. This is 5. This has to be 5. It can't be 6 because of the 6 in the row. Can't be 3 or 8 because of 3 and the 8 in the column. This digit cannot be 3, 6, or 8, which is the only digits remaining in the blue region. So this is a border here. So this must go down here. And it cannot be 3 or 8, so this has to be a 6. Okay. We need 3 and 8 for the blue region now. It cannot be, I guess it could be, can't be 3 here. So none of these, this can't be 3 or 8, so that's a boundary there. In fact, actually, that's 9 cells in column 8, so that's already limited. It cannot be I guess it could be 8 here. It has to go somewhere one of these cells. Okay, this blue needs access to a 3 or 8. This can't be 3 or 8, so this is not possible to be on the line in the blue region. This can't be 3 or 8, so this is also not possible to be in the blue region. So it could go here. Okay. And then one of these two is an 8. It cannot go down here, because if it tries to go down here, this would have to be 3, then 8, and that's not possible because of the 3 in the column. So 8 is one of these two. Okay. The orange needs access to a 1. Where is it going to get access to a 1? We already have 1, 2 connection, so it's 3, 4, 5, 6 connection. 1, 2, 3, 4, 5, 6, 7, 8. We need access to a 1, so we can only have it 1 away. This can't be 1. This could be 1, but we don't have access to it. None of these can be 1. These can't be 1, and these can't be 1. So the only place where we have access to a 1 is over here as an orange. To connect to that, can you connect this way? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No. So it must connect that way. And we know this will be seen as one of these, so this must be 5. This has to be a 4. And we need access to a 6 for the orange. Is that right? 1, 2, 3, 4, 5, 6, 7, 8. Yep, we need a 6, and it can't be here. So this must be 6 here, which is orange. So that's the full boundaries. Oops. For the orange region. Okay. Where is the... Okay, so... For the orange region, we can count how many cells. This sees 5. So this sees 4 here. These 3 cells see 4, and none of them are 4. This sees 7, and none of them are 7. These two see 4, and none of them are 4. This sees 5, that's fine. This sees 3, and this sees 2. That's fine. So now we just have the blue region, which we need to check. If this were 6, 3, and 8, the 3 would see 3 cells. So it cannot go here as a 3. Therefore, this must be a 3 here. And we can no longer reach that, so it must be here as the cell. And let's check it before we actually just finish it off. This 4 sees 2 cells. The 9 sees 7. The 2 sees 7. The 7 sees 6. The 1 sees 6. The 5 sees 6. The 6 sees 7. And the 8 sees 2. So that's a solution. Oh, that didn't solve it, though. Did we not solve? Oh, we have a 0. There we go. So that's a solution. Yeah, very hard in the sense that it takes a lot of time to get through. The logic behind it, though, was always very satisfying, I guess, in a sense. It was interesting resolutions that you had to have. This was nearly 3 hours, but yeah, I mean, I didn't want to create another video for this, and it seemed like I was pretty close. I wasn't that close, I guess, but the logic behind it was pretty, how do you say it? There was a lot of interesting logic involved. So yeah, very cool. Nice little puzzle. Yeah, if you have 3 hours, hopefully doing it yourself or watching me do it, it takes a while to do that. And that's the case for most very hard puzzles anyways. So, but it's kind of satisfying at the end when you finish it, right? It's like, oh, this was fun, you know? And it never felt like I was really stuck any part of the way here. It was just basically getting through everything that you needed to solve for the regions, really. Um, the logic behind this, I hope the logic behind the circles made sense, right? I don't know if I explained it very well, but it's basically, yeah, the restrictions you had for the loop forced certain places to be certain regions. Very cool though. Very nice puzzle with satisfying. The logic throughout was very good, and it never felt like you were stuck, but you had to get through a lot to actually solve everything, right? So, anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.